Welcome to This is Bitcoin, a series of videos that will explain in detail what Bitcoin is and how it works. This probably won't be like any other videos you've seen on Bitcoin because I'm not going to talk about the philosophies and whether you should believe in its money value. What we're talking about are the actual mechanics that go on to accomplish a Bitcoin. This particular image you're seeing here is a listing of the directories of Bitcoin. Each of these white blocks is a folder into which there are files that make up the source code for Bitcoin. Now, when these get compiled, the directory structure might be different, but for the purpose of reading code and following what it does, we will be looking at the source code, and therefore all of these directories will be in these folders. Okay, among the directories of the standard off-the-shelf Bitcoin Core wallet is bench, compat, config, consensus, crypto index interfaces, logging, node, policy, primitives, of course Qt, because this is a Qt graphic Bitcoin wallet, RPC, script, SecP256K1, which is the encryption system, a support directory, a univalue directory, a util directory, a directory called wallet, and a ZMQ directory for the messaging system. Inside these directories, you'll find a number of code files, and these code files are each CPP code. That means that they're C++ source code, and you can see quite a long list of source code here. And if you simply go to the doxygen.bitcoin.org, you can see everything I'm showing you. And you see, now every one of these files does something. And if you're going to understand Bitcoin thoroughly from the internal operation, you'll want to know what each one of these files does, or the code that compiles from it, what it does. Remember, the .h files are header files that basically are preprocessors for the code that is being compiled, and the CPP files are C++ source code files. Now, there's another way of looking at all this same stuff that we're looking at, and that is by looking at modules. And here's a list of modules. Now, bear in mind that more than one module can be in the same file. But each of these modules, it shows that this module is in wallet, and it is found at about line number 996. And it's the abandoned transaction module. This is a Doxygen map of what functions are called and call back from that module. Okay, add to spend module. No pretty picture for that one. Add to wallet. Well, this one gets a little complicated. Now, this is the add to wallet module, and it is actually wider than the image here. And we will go through each one of these things and discuss what they do and what their purpose is. I would like a better annotation on some of this, but when you look at the source code, you can actually see what it does, and from that we can infer what the annotation would be. In some cases, I will be telling you what I believe with a low or high level of certainty a particular module's purpose and function is, when the purpose and function appears to be ambiguous, or at least appears to me to be ambiguous. And so if you see something where I've got it wrong, or more likely I simply don't know that particular function, then you can message me directly and give me the details, and I will edit the presentation for that section, including the details. See, this is a calculate maximum signed input size. Okay. Calculate maximum signed TX size. Change the wallet passphrase. Dummy sign input. Okay. Encrypt wallet. You can scroll through these at the URL that appears at the top here, doxygen.bitcoin, and this is basically the group map of the wallet. And here, this blob of stuff is found at line 1571 in the wallet CPP. And this is how the functions call each other. Now, this is electronically generated by looking at what each function calls, and the condition, how frequently or infrequently a particular call is made, isn't indicated here. All these arrows do is show you that a call under some conditional circumstance might be made in each direction of each of these arrows. It's possible that occasionally in the code the conditions will be such that an arrow would never ever be used, but if it has the call pointing somewhere within the code, all that Doxygen can do is assume that it might happen and include the arrow for us to look at. So it won't really be until we look at each of the source codes files, and you'll see most of this is in the wallet.cpp. That's because we're looking at the group map of the wallet itself. Okay, we're about 2/3 of the way down. I will just scroll through these gradually because my screen capture won't show the entire thing anyways, so you may have to go to I think that's showing that whole screen, but you may have to go to the Doxygen for Bitcoin and actually look at this. Now, it's a good idea to browse through this and have some idea what you're going to expect the functions to be doing depending on each thing that's called. And that way, when you go into the software, if it's ambiguous and you can't really tell what the source code is calling or is coming back from a call to do, you match it up with one of these graphs and have some understanding. It looks like we're almost at the very bottom of this particular And so that is the map wallet functions, and this is the actions. It looks like some of these are much bigger, at least this one is. Now here's a commonly used function, which is a create transaction. You bring up your wallet and create a transaction each time you want to buy or sell, and get address balances. Okay. Get address groupings. The get balance function. Now bear in mind that all these balances are numbers of coins, or percentages of coins. The software itself has no idea what that coin might actually be worth. That has to be externally determined based on some brokerage or somebody who might want a coin from you based on what they're willing to give you for it. And here's the load wallet function. Mark destinations dirty. Okay, so that old information is appropriately marked and not used as current information. All right. And so that completes a visual overlook of the internal workings of Bitcoin. And we'll start going through individual functions with the next episode.